Swayam Prabha. Digital India. Educated India.
Are we good to start? Is everyone here, or should we wait for some more time? Okay. I think we'll get started. This is my first time teaching to the school kids of group theory, and I would prefer that you, during the session, you think more rather than taking notes. Ask questions between your friends and also to me. Whenever you get doubts, raise your hands. My goal is to make you think and become comfortable with whatever that is being done here. Okay. My preference is close your notebooks, write on them only if necessary. Try to think along. Okay. So what are the number systems that you are aware of? What are the number systems that you are aware of? You can share some of them, and the rule is like, if you have some answers, raise your hand, so that if you tell your answers out loud, other people will stop thinking. So I want everyone to think. So if you have an answer, you can raise your hand. Are you aware of any number system? And if you want to share something, yeah. Okay. Binary, decimal, octal. Okay. Okay. Fine. I'm expecting some other things. You can keep on going on that. N-based numbers. That's fine. Okay. Real number system. Are you aware of this symbol? Is anyone not aware of this symbol? Okay. So this refers to real numbers. So something that you see in everyday. Okay. I'll write complex numbers. Integers. Then periodics. Okay, we'll not go into that, but we'll stop. Any other thing? Someone was telling something. Okay. So some of these things we keep seeing in our everyday life, right? When you look at time, when you look at temperature, or most of the things you will keep seeing. Are there some other things that you see in your daily life that is not here? Okay, if you want, I'll write that, but something more that you keep seeing every day. In the sense they behave very different from how these numbers behave. Something that you keep seeing every day. No, that's just writing different form. I want their behavior to be different. Yeah. Exactly. So now the time is 9. Say it's 9. Like 1 hour, when we go add 1 hour, it becomes 10. But what happens if we add 5 hours? 2 o'clock, right? But when you do that process in natural numbers, 9 plus 5 is not 2. So what are those things are called as? Okay. So first let's try to understand whatever the thing that she has told. Let us start with 0th hour, 1, 2, up to until what I can go. Let us use the military. So it goes 23 hours, right? When I go 1 hour after, I come back to 0. So this is called as Z24. Okay. So basically what happens here, how does it behave? It goes from 1 up to a certain number. When you add it, you just add and divide by this and take the remainder. So when you add 1 to 23, what do you get? 24 hours. When you divide by 24, what is the remainder? 0. For example, the way we took her example, what was that? We considered instead of 24 hours, we considered 0 to 11, 12, right? So when you take 9 as the current time, how much did we add? 5. So how do we figure out what is the time in this 14? But when you divide by 12 and take the remainder, equals to. So that was Z12, where we had 0, 1 up to 11. So we picked 9 here, added 5 to it, and then the remainder is, we want something again in this set. We don't want to go out of the system. Okay, so we don't. So now the question is, can you think of other examples that you come across which behaves in this manner? Interesting. Degree. Okay, but when you say degree, what do you mean? Like, how do you want to write that as a set? Any angles? Okay. So do you want to say something like all numbers between 0 and 2 pi? Something like this. Here the sets are finite, but this is an example where the set is infinite. Okay. Any other examples? I would like you to think of more finite examples. Again, something from the daily life that you see, which happens in yeah, exactly, days of the week. You had an answer? Huh? Since this is infinite thing, which we don't want to touch right now, we can discuss this after the session. We can have a conversation about it. Okay, days of the week is one thing. If you want to represent this in terms of, say, numbers, say like today is Wednesday, right? Or let's call it day 0. So 0 corresponds to Wednesday, 1 corresponds to, 6 corresponds to Tuesday, and then once you go to the 7th day from now, that becomes, which is Wednesday. So just by using this, if you get to understand this idea, you will be able to come up with a formula for given a date. How do you figure out the day of the date? Okay, let's just make it very simple. Today is 29th of May, right? Which is day 0 we are considering here, which is a Wednesday. What about the June 1st? It is, today is 28th, 29th is day 1. So 29th, 30th, 31, and then 1st, which is 3. So 3 corresponds to, okay. Now what about July 1st? Can you count the number of days, which day number, and then all that you have to do is divide by 7 and find the remainder. So what will be the day 100 now? Okay, what is day 0? Wednesday. What is day 1? The Thursday. What is day 6? Tuesday. Day 7? Okay. Day 10? Same as day 3? Saturday? Same as day 3? So how did you figure out day 100 is Friday? Yeah, 100 modulo 7 is 2, and 2 corresponds to day Friday here. So now if you spend some more time, you should be able to figure out, given a day, how do you figure out the date? We can come up with a formula. And the way, like if anyone is interested, you can talk about that later. Let's come back to this kind of system. Okay. So now what I would like you to do is, now let's just take this example, and then I want you to create a table on your notebook. Okay, so similarly write 4, no 7. Okay. Now what is the operation that we can do here? Take two numbers and then add them, and then they end up in the same set. Now I would like you to fill this table in your notebook. Remember that the operation that you are doing is addition. However, the addition here happens in a way you add them and then find the remainder when divided by 7. Is any group done? If you are done, you can help your friends to finish it. Yeah, and then the entries should be between 0 and 6 from the same set. Okay. Okay, I'll just tell quickly what are you supposed to do. So this entry needs to add 0 and 0. 0 and 0 is going to be 0. Okay. Suppose take this entry 6 and 2. If I add it, the number is 8. But I want the entries to be from this set. So find the remainder when divided by 7. So 8 remainder is going to be 1. Right. So similarly, I would like you to fill the whole box. If you are done, see if you observe any pattern there. Why is this 1? 7 divided by 0. See if you observe any pattern. We will eventually try to observe more patterns from these tables. So the thing that very informally that I want to define is that you have a set, right? And you have an operation on the set. What binary operation? What does binary operation mean? Take two elements and then it combines to give you a new element, a single element. Now you know exactly that's what you have done. Any two elements if you take, you know exactly what is a new element that's going to come. So the way this new element is produced, you have certain rules on them, which we will eventually see in the class today. Okay. So a group is said to be a set together with a binary operation satisfying some conditions, and that condition you can eventually see as patterns in the table that you have written or in the more tables that you will be writing. Okay. So with this in hand, I would like to ask, is anyone still like not able to get the table? Okay. If so, discuss with your friends. I think most of you have got it. The next thing that I want to say is, like, do you see this? So I would like you to see this as an configuration of an molecule. You have an atom here, and these dots are basically atoms. Now the question is, can you do some operation on this? In the sense, let me even ask a simpler question before this. Let me give you a equilateral triangle. Okay. Now the thing is, like, I can close my eyes and you can do whatever you want to do with the triangle. And if the hint is like bingo ad. So when I open my eyes back, I should see the same triangle, right? So what are the operations that you can do on the triangle? Rotation. What is the next thing you told? Flip it twice. So what do you mean by flipping? Take this, flip it this way, then it will look like a downward arrow for me, right? Then okay, then it's the same thing. Okay, flip it twice. So there are a lot of answers for me. Let's go one step at a time. Whoever I told rotation by what? I can just rotate it this way. It will rotate by no 120 degree, right? Because the total rotation is 360 degree. I have to rotate it like 1/3 of it, so which is 120 degree. So rotation by 120 degree. Then okay, reflection about what? About right. So about this line, the perpendicular. Take this line and then you reflect. It will give you the same triangle. Perfect. Okay. So let me call it the reflection as F for now. Okay. And this reflection is about this point. Okay. Now there is some more rotation that you have missed. Okay. What do you mean by horizontally flipping? Do you mean this way? Okay. Isn't it what we are flipping? Like the axis? Right. So isn't it what we denoted as F? Yes. Okay. Okay. Yeah, can you repeat your answer? No, okay. Let me take the triangle. What should I do now? This one. Okay, now. So I have to rotate something now. What to rotate? So if I rotate this 180 degree, then the whole triangle will become downward. Okay. Okay. Rotate 180. Okay. In the sense like reflection. Exactly. So here also I can do the reflection or flipping with respect to this. And there are totally three flippings that I can do. Okay. What about rotations? How many rotations I can do? Exactly. So if I rotate once, it just this comes here, this goes here, this goes here. I can rotate one more time so that is R240, right? And if I do it one more time, then what happens? That is same as R0, right? R0. Okay. Now I have not written two more reflections that are possible here, right? Other things I have written. So now the thing is like, let me write 1, 2, and 3. What are these things? Reflection about this altitude and this and the third thing. So there are 3 possible. Now the thing is like this whole thing. Now you can compose them. In the sense, you can flip and then rotate. It will still be a triangle. Now the thing is like, I want you to take this set. How many elements are there? 6. And these are symmetry preserving transformations of a triangle. So whenever you perform, the triangle remains a triangle. Now you can combine them, right? Like how did you get R240? You can do it twice to get R240. You can rotate twice 120 degree to get a rotation of 240 degrees. Now what will happen if you mix them? Can you tell me what happens? It will be the same thing. Okay, let me ask more precisely. You are doing 120 degree rotation combined with F1. So what are you going to do first? You are going to flip the triangle and then rotate it by 120 degree. What will that be equal to? See, if you remember exactly what did we do? We took 2 elements to produce 1 element. So what is that 1 element here? Which one? But it will, okay, so she is telling it will be the same triangle. It will look like the same triangle. But the point is like, you call it A, B, C. Okay. Now the point is like when you do a flipping, it will be A, C, B. There is a difference, right? Even though it appears same, but it's not the same triangle. Okay. So the question is, when you do this combination, you want to produce one single element. What will that be? How do you think about it? You start by naming ABC and then try to see what happens when you apply each of these things. Okay. Can you repeat your argument? Okay. That's 240-degree rotation. Is that what you're telling? You're telling rotate 180-degree and then 60-degree. You'll get 240-degree rotation. But what is this? Let me try to do it for you for once. So what? First I'm going to flip it, correct? So this triangle is going to become. So I'm going to flip with respect to this altitude. Where will A be? No. That was the mistake. So while flipping, this remains the same. You just like flip it this way. So B and C interchanges. Okay. This comes after applying F1. Okay. Now what happens to you apply R 120-degree. What happens to this? A comes here, C, B. So this is just rotated 120 degrees. You get this. Now the question is, when you do this combination, you want to get one single element here. What will that element be? Okay. Why? So his point is he is telling it is same as F3, which is the flipping with respect to this. Why did you come up? Why did you think that way? Exactly. So the thing is like C vertex remains the same, right? Only A and B are interchanged. So that's exactly flipping with respect to this. Okay. So can you write down the table for this? So you know the elements exactly, right? I will write for you in an order that will be helpful for you to do. R0, R120, R240, F1, F2, F3, right? You expect the same thing as last diagram? As what you did for Z, sir? No, you are wrong. You can try to do and then tell me what is the difference. Not exactly. There is some more bigger difference in this. And if you are able to try to do one step at a time, I gave you an example. How do you figure out when combination of two? How to figure out? Take a triangle, name it ABC, apply one, and then apply the second. Then see what happens. Hi, welcome. Yeah. It's fine. It's first time we doing something like this for school, right? So, your suggestions? No.
Discussing among groups, I'm just curious whether they're discussing the relevant terms only.
Yeah?
Whether they're discussing relevant terms only.
You're curious whether that's happening or not. Some people are distracted, so that's happening. I've observed it. I think it's better than what I observed. So I'm happy. So if you as a group have some doubts, just raise your hands. We'll come and help you. Do you want help? No. Yes. What is ABC? No. You have to write it as the elements. So ABC are just like vertices of a triangle. these are the transformations that you are working with. So the set, let me just. So, like the thing that I want you to write is, remember earlier we said group is a set of elements together with a binary operation. What is the set here? R0. So when you say binary, you take two elements from this set, you combine them and you have to produce elements in the same set, right? So for example, we combined R120 with F1, what did we get? F3. Which one of the following? I did not get your point. Can you repeat again? Okay, I understand. Okay, I get your point. So many of you are having what is F1, F2, F3, right? So I will write it as FA, FB, FC. So what does it mean? This FA fixes A and then flips BC. FB fixes B and flips AC. FC fixes C and flips AB. Right. Good point. So she asked the question of, are we doing an anti-clockwise rotation or clockwise rotation? We are doing anti-clockwise rotation. Yes. Has any group crossed writing more than 3 entries of a table? If not, call me and we'll come and help.
One doubt here.
Yes.
So do we flip first or do we rotate first in this case?
So take the things here as the first action and this is the second action.
Oh, sir, I took the reverse.
That's also fine. Then what you have to do is you have to transpose the table. Just letting you know, take the operation here first and then do the operation here as the next thing. For example, we first did F1 and then applied 120 degree, right? So for example, if you want to do the other way, that is first apply R120 and then apply F1. So that entry will be here. I'm not sure whether they both will be same. You can think about it. Okay, where are you guys as a group? So other thing is like you can discuss as a group. Since you are seated in a group, you are free to discuss among yourselves. What are you trying to do?
How do you find the reminder like in the previous case when we don't have matrix?
Here? Here it is not about reminders. It's about what happens to the triangle. Okay. Why don't you draw a triangle? Let's try to see what happens to an entry. Draw a triangle and name it ABC. Right? Okay. So now the thing is like you want to find some entries. Tell me, okay, I would like to address you all as a group so that you see, let's see what happens here and then you can, later you can figure things by yourself. Which entry of the table do you want to fill now?
R0.
No, you can suggest something. So which entry? I want some entry in the table that you want to fix. Which one? So R 240 and F1. So this entry, right? So just we are going to find this. What is this thing? F1 composite or just like, and then 240. First you want to apply R240 and then apply F1 and then figure out what happens. So for this, what is the first thing that you're going to apply? What happens when you apply this? Write the new triangle. You're going to rotate it? Yeah. Perfect. Right. Now what happens when you apply this? F1?
F1 is keeping in constant.
Correct. The point with the writing FA is, after rotation, A will become a different place, right?
They have observed some pattern. So they have written like 1 or 2 entries from history and now using pattern they are just filling.
Oh, okay. That's good. What happens?
B and C.
No, the thing is like this A is like top thing, so that remains fixed.
Okay, we have to take the foot here.
Exactly,
Not from the
exactly. No. You have to take from here, but the flipping is happens of where the A position in the original thing. So here it's B.
changes from
Only this flip. So when F1 happens, it's because of bad way of writing the notation. So this F1 is basically flipping by fixing the top thing. So what is top here? B. Fix it and flip the remaining two. Can you write the new? Exactly. So it should not be FA, it should be F top kind of thing.
So F2 means we have to flip according to
We have
the
to
top.
keep this place constant and then
F2.
Yeah, whatever sheet. Now can you figure out what this is? So we'll just talk. So now writing down the KLA table. After this, we'll ask them to think about what happens for square and then higher things. And then we'll just tell them this as applications, these bars and other things, this freeze groups, crystallography and things like that. And then end there. So a better way of writing this would be, actually if you see, how many of you have observed the pattern that whenever you write this, so this table is called KLA table. Given a group, how does two elements interact? That's exactly given by this table, which is called as KLA table. So have you observed some patterns so far? Yeah, you can share your patterns. What did you observe? Okay. This one? The off diagonal, like this thing. Okay, interesting. Interesting. So you are telling it's going to have F1 here, and this is going to have F1, F1, F1. Interesting. So here. Okay, can you repeat? This off diagonal. Okay. Here? Correct. Okay. This is quite easy to see because if you do a same flipping twice, you get the same triangle, right? And R0 corresponding to making no changes to the triangle. ABC remains ABC, no changes at all, right? So, nice observation. Are there other observations that are common to both the tables that you have observed? I've seen some people filling that. Oh. Okay. 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 But are those two tables same which you said at the beginning? Right. Okay. So how many of you observe that the first column and the first row is exactly replication of what is here? That is because this element fixes every other element. So such an element is called as identity element. So in a group you will always have an identity element. What is the identity element in Z6? 0. Right. What is the identity element in Z24? 0. Okay. So whenever you see a group, you can ask the question, what is the identity element? Okay. Now another thing that you can observe is, whatever element that you pick in the table, you can always get another element in the group such that when you combine them both, you will get the identity element. So what does it mean? Whatever transformation that you do to a triangle, there is another transformation which when you apply will nullify and you get back the original triangle back. So that property is called inverse. So what does inverse say? Given any element in this set, there is always another element. When you combine, you will end up with the identity, right? Okay. So these are a couple of observations for now. Let me ask one simple question which I wrote there earlier. So you see the molecule structure there, right? Now, whatever you have done to triangle, similarly, I would like you to think for that, and how many operations can you do on that molecule structure so that the structure remains the same? How many operations do you think you can do? Okay, rotation is one thing. Of how many degrees? 3. 0 degree, 120 degree, 240 degree. What about other transformations that can be done? Can anything more be done there? What about reflection? Correct. When you reflect, what will happen is, this thing that's on this direction, when you reflect, that will flip to the other. That's a different configuration. So, for that, the only symmetry that is possible, there are 3 elements, rotations alone, right? So, in fact, if you write the Cayley table for it, you can think about the Cayley table for it later on. Now, couple of other things that I would like you to think when you go back is, now you have thought for a triangle, right? Now, equilateral triangle. Now, you can think for a square. What are the possible transformations that you can do such that it preserves the square? And once you do this, I really ask you to do this for triangle and square. Once you do it, you can observe some pattern so that you can tell what happens for a regular polygon, N polygon. Yeah, try to do it for square, then you will observe some pattern, and then with that you can see what happens. Probably you can note it down and you can do it later. For now, I would like you to switch on to the next things. So, what are these groups are called as, in the sense, you are collecting all those transformations which preserves the symmetry of the underlying object, right? You have a triangle, then you can think for square, you can think for polygons and so on. So, these groups are called as dihedral groups. And one hint that I can give you is, how many elements are there in the dihedral group for triangle? 6. So, if you take square, there will be 8 elements. If you take n polygon, the dihedral group corresponding to, exactly, it will have 2n elements. It will have 2n elements. So, when you are trying to look for symmetries of a square, once you get 8 elements, you have got everything. Then try to work on the Cayley table, building the Cayley table. Okay. So, now apart from this, these are a couple of nice things. Now, I would like to move to next examples. So think of this, some graph or something, and I would like you to think about, these are like 1 unit you have a bar, 1 unit have a space, 1 unit bar, and it continues and so on. Okay. So now what about the symmetry of this? What transformation can you make? What are the transformations that you can make so that, can you come up with some transformations that you can make on this so that the object remains the same? Rotation, yeah. No, reflection. So okay, reflection with respect to what? Y-axis. Okay. So if for that we need equal distance on both sides, right? Only then. So if suppose there is equal distance on both sides, then reflection with respect to y-axis will work. You have an answer? I'm sorry. Say the same thing. Okay. Okay. Any other possibilities? There is something new here. That's why I have written this example. Rotation by 180 degree. Will that work? Rotation by 180 degree. What will happen? When you rotate 180 degree, these bars will go below. They are different. Rotation by 360 degree. Is it the same thing? Okay. That's the identity element, by the way. Any other transformations that you can make? There is something different from the triangles that you have seen here. Let's see if someone can come up. There is one transformation that you can make to this. It will preserve. One thing is reflection that you have got. There is one more. Exactly. Exactly. So translate. So when you translate by how many units? 1 unit. Then you will get this. You will see the same figure again, right? Translate by 1 unit. Then what happens? Oh, will you see the same thing? If you translate by, exactly, 2 units. If you translate by 1 unit, all the blank space will be filled and the filled space will become blank. So if you translate by 2, exactly it jumps here and the space jumps here. So translate is one thing. So call it translate by 2 units. So what about other possible translations? So I can translate by any 2 ones, and I have a reflection, 1 reflection. Now I can reflect with respect to keeping my thing over here in the middle over here, in the middle over here. I have so many reflections that I can do depending on where I place it. So now you can think about how many reflections that you have to write, and when you collect all of this, so let me take this as reflection 1, and this reflection happens by doing it on this specific bar in the middle of it. I can reflect so that this exactly flipped. This space comes here, this space goes here, and exactly they are flipped. Okay. Now, can you think of one more reflection? Along the that will be the same thing, right? There is no changes. Like this is not a bar. Yeah. Okay. Someone else was telling it. Yeah, you have a point. Okay. Exactly. So this reflection with respect to the filled space. Now you take a blank space here or even the y-axis, right? Now those two are different, right? Let me call it as R2. Okay. Now what about, okay, this is the second reflection R2. What about this thing? This reflection. With respect to this also I can reflect. Is it same as first doing exactly, translate and reflection. So basically you collect T2n where n varies over z, R1, R2 and all their possible combinations. So that becomes the symmetry group or the transformation which preserves the symmetry of this object. Now let me make some small change to it and ask what will be the, instead of straight line, for half unit straight line and half unit slash. Straight, one unit gap of. Okay. Now what will be the symmetry of this? I can keep on writing. Translates will be there for sure. Yeah. T2n will be there. Okay. Then reflection with respect to what? Okay, so if I reflect, will it remain the same? So this slant will actually, this slant will, and I reflect, it will become this slant. They are different, right? So there are like, so you can actually form how many kind of different things can you form? So T2n is the only possible symmetry for this. Now how many possible such kind of arrangements are possible? There are actually totally 7, and their corresponding groups are called as Friese groups. My spelling might be wrong, but yeah. And in crystallography, where they try to study how the atoms are arranged in a crystal, and in crystal the atoms are arranged in a repeating pattern. So they want to understand what is the pattern, and that happens to be one of these 7. So there are similarly, and like there are something called wallpaper groups, which are like totally 17 of them are there, where the arrangements are not like just this way, it's the whole plane. For example, many designs that we see in architecture, like in the buildings, paintings and so on, there we can see these patterns repeating. So it can take some time, try to go through, recollect whatever that has happened now in the last session. So we saw some examples of groups. We started with this, and then we observed groups means a set where given any 2 elements, you should be able to produce a new element. And we also saw some more things, like there should be an identity element. That is, that element when you multiply with any other element, it should give you back the same element. So that's what is the first row and first column remaining the same. And given any element, there exists another element such that when you multiply them, they give you back the identity. That is, if you think of groups in terms of transformation, you take something, you transform. There is also another element in the group. When you apply that transform, it gives you back the same element, right? So now the group is a set which has a binary operation, which means 2 elements combines to give a new element satisfying some properties. Now groups can naturally arise by looking at the symmetries that are preserved by the objects like triangles, squares and so on. So try to recollect whatever that has happened, take 30 seconds, try to recollect whatever that has happened in the past session, and then we'll take a break. So 30 seconds, after that we'll take a 10 minutes break.